Two similar cylinders are stacked one upon the other. Assume the bottom one is resting on a table. What is the ratio of the surface areas open to the air of the small and large cylinders? All right, let's begin by looking for the surface area of the top or smaller cylinder that we have. And that's going to consist of the area of the top, because only one of them exposed. The bottom of this cylinder is not exposed. So that's going to be the area of the top. And that's going to be equal to pi times the radius. Well, the diameter is 3, so the radius is 1.5, or 1 5/10 squared. So we're going to have 2 25/100, or 2 1/4 pi when we multiply 1.5 times itself. Now we also have to find the lateral area, or this area going around the top. And that lateral area of the top cylinder is going to be equal to either 2 pi r times the height, or you could do pi times d times the height. Since we're given the diameter of our top circle, we're going to use pi times the diameter of 3, and then the height of the cylinder is also 3. When we multiply them together, we end up getting 9 pi. So therefore, the entire surface area of the top is going to be 2 25/100 pi plus 9 pi. So we get the total surface area for the top is equal to 11 25/100 pi square units. Now let's find the surface area of our bottom cylinder, or at least the surface area that's exposed in this bottom cylinder. So we have this top. The entire top of this is not being exposed, only the outer section. So the area of this top is going to be equal to pi times our outer radius squared. That's going to be, this is going to be our capital R, minus pi times our inner radius squared. And that inner radius is going to be this value. Oh wait, that's the radius of our small cylinder. So we can fill that in right away. So we have pi times 1.5 squared. Now we got to figure out what this outer radius, or the bigger radius, is. So notice the diameter to height is the same. So if this height is 5, this entire diameter is also 5, making the bigger radius, or capital R, be 2.5, or 5/2. And now if we evaluate these and then simplify, we'll end up getting 2.5 squared is 6 25/100. You could also think of it as counting 25 quarters. If you have 25 quarters, you have $6.25. Minus, we already found what 1.5 squared. It's 2 1/4, or 2 25/100 pi. And if we subtract these, we end up getting that the area of this top section is equal to 4 pi. Now we have to find the lateral area of the bottom. And that's going to be equal to pi times the diameter of our top is 5, and then the height of this bottom cylinder is also 5. So that's going to be 25 pi for the lateral area of the bottom. And then if we add up to find the surface area of the bottom, our two areas that we have for the bottom, 4 pi and 25 pi, we end up getting 29 pi as the surface area of our bottom. And now if we set up our ratio, we will have 11 25/100 pi over 29 pi. Well, the pi's cancel out, and we can also multiply both the numerator and denominator by 100 in order to get whole numbers in the numerator and denominator. So that'll be 1,125 over 2,900. And then if you divide both of those by 25, you will end up getting 45 over 116, which is answer choice D.